The original Dinosaur game was created by Google in September 2014 for the Google Chrome web browser. It is a simple game where the user controls a dinosaur that has to jump over obstacles with the press of a single key. I decided to combine my passion for coding, gaming, and dinosaurs so I could create a new approach to this game. And these are the main results of that project. So, this is the good, the bad, and the ugly way of playing the Chrome Dino game. Before we start, it's important to mention that nowadays there are multiple versions of this game. I decided to test my code with the one you see on screen. Having said that, we start with the good, also known as the correct way of playing the game. Whenever you press the spacebar, the dinosaur jumps. This is how we can make our character avoid the different obstacles that appear. It is one of those cases where the game is easy to learn but hard to master. Now, the bad way of doing things involves cheating. We do so by creating a Python script that plays for us. We'll use a very powerful library in Python called PyAutoGUI. It stands for Python Automatic Graphical User Interface. We will use it for two tasks. For identifying when should our dinosaur jump, and secondly, yes, for making it jump. We'll also use the time and system libraries for our script, and we can display any type of message that we want. We'll need to actually start playing the game and take a screenshot of a section that shows the upper body of the dinosaur and a little bit of white space to the right. We mainly include the white space to give our script time to identify obstacles. So, we simply take our screenshot directly from the game, we save it and reference it in our code, and then we can define some extra parameters. For identifying our target image, we don't have to be 100% sure that we have found it. In fact, a value of 90% will achieve better results. Now, it wouldn't be very efficient to scan the whole screen just to find a tiny image that has a low resolution. That's why we define two variables for our x-axis and our y-axis. We use them to subtract pixels from the resolution of our monitor. This simply means that we want to make sure that we don't have to scan the whole screen to find our target image. We'll see in a moment how to use these variables to improve the performance of our script. If you are an experienced developer, you can simply adjust these values for your own resolution. If it is confusing, you can simply remove these variables and any mention in the original script, and it will still work. Now we're going to define the main logic for our program. Right now we have just identified a target image of the dinosaur and some white space. Our program runs as an infinite loop, and we can simply stop the execution of it at any time with Ctrl+C. When we're identifying our target image, we need to have OpenCV installed so we can specify the value of 90% that we declared earlier. You can see the command on screen to install OpenCV. The main logic of our program is here. It simply means that if our script doesn't identify the target image, it will send a command to jump, which simply consists of pressing the spacebar once. Why does this work? Well, we're always scanning our screen for that original target image with our dinosaur and white space to the right. If any type of obstacle appears, then the program won't be able to find our original target image and will send the command to jump. And with that, we go into the ugly approach. Don't let this name fool you though. Is it unorthodox? Well, yes. Is it unnecessarily complicated? That too, because we just showed how we can do it with only software, while this other method requires hardware. However, it is a great example of what we can achieve with Arduino. And to be honest, when it comes to personal preference, and I have done both methods, I find this one to be the most enjoyable when it comes to setting up everything and also watching it work. I made this simulation using Tinkercad so you can see what the whole circuit looks like, what it is supposed to do, and how we are supposed to connect the different components. So here's the main idea. The obstacles in our game are always black and the background is white. We can detect those changes in brightness using a photoresistor, and whenever we do detect one, send a signal to our servo motor so that it can physically press the spacebar in our keyboard. As you can see on screen, I include the source code that I use for this particular example. However, if you want to try it out and start from scratch, maybe you'll need to change some of the delays depending on how you implemented it. It depends on a lot of factors. For example, the hardware that you have available, which components do you have, the value of resistance you're using, how you're handling the servo motor, your pin layout. So be sure to double check everything. Use from this example whatever works for you. And just consider that when you actually start working on it, testing it, you might need to make certain adjustments depending on your requirements. So that's it. If you want to try one of these projects by yourself, the source code is in the description. My name is Sol Figueroa, and thanks for watching.